What if your car could produce 25 gigabytes of data every hour? Most people wouldn't know how much data that was, but simply put, it's about 100 hours of video or a PowerPoint presentation for each county in the U.S. In case you were wondering, we have about 3,140 counties. If that's not descriptive enough, 25 gigabytes is about 1.5 million Word documents on your laptop or 17,500 listening minutes of your favorite songs. Why does this matter? Well, John Ellis, global technologist, connected services at the Ford Motor Company, and also the head of the Ford Developer Program, also at the Ford Motor Company, is here to tell us why. And John, welcome to the program.
Thanks very much, Ed. I appreciate the invitation and the opportunity to talk to you and your listeners.
Well, we appreciate you being here. We know you have a busy schedule. Let's start off right away talking about the fact that there are about roughly, and correct me if I'm wrong, about 20,000 parts on a typical Ford vehicle. How close are you to developing ways to collect data from those vehicles that will have a significant impact on the consumer experience?
We're close, but it's going to take a while, and it's going to be in phases. I think from the listening standpoint, it won't come as one big bang. It will come over many years. We're close to collecting individual pieces from the infotainment, speed, velocity, some of the more safety critical stuff as well. We're close to being able to deliver them off-board. That means from the vehicle to somewhere else to be able to do something with them. And we're able to do stuff with them after the fact to help make the drive a little bit safer, the car and the maintenance of the car a little bit easier. So it's happening today in small bits, and over the next 3 to 5 years, exciting period of time for us as we begin to instrument the vehicle. Number one, instrument meaning to be able to actually put the things in place that would allow for the vehicle to generate the data, and then be able to collect and then ultimately distribute and then process that data into meaningful ways to enhance the car driving experience.
I know you have 3 categories per se of data that you extract, or that you call data that you extract from these vehicles. One is internal data, one is external, and you also have sensor data. What kind of visibility do you have for these vehicles regarding internal, external, and sensor data?
Yeah, the internal data is predominantly that which, for those that are listening, is that which might be related to your powertrain or to the actual engine. And so that's the revolutions per second, how much combustion burn, the oxygenation, things of that nature. There's about 66 computers on a modern day car. Anywhere between 50 million and 100 million lines of software code. And so they're used to generate lots of different data from the standpoint of understanding how fast to move the engine, how fast to start it, when you hit your brakes, being able to stop. That data is internal, and we use it internally for our consumption. We're trying to figure out ways that we could use it externally, that is to take it and export it externally, see how that works. Right now that data is available to you in a car or the dealer. The external data is data that we would get then from some of the other types of things, for instance, wheel speed, where you're at, your direction, your GPS. Those kinds of data right now are available to us, again, in some form or fashion. We use some of it for your ability to do, say, for instance, traffic and traffic management, to be able to give you a routing, say, for instance, if you're using a navigation unit. And then the third piece is sort of the data that is the sensors, that's either our own sensors, that is sensors Ford puts on, or sensors that a third party might put on. For example, if you look at Ford's Interceptor, which is an LAPD a police car, there's a number of different sensors that are put on aftermarket. That kind of data right now is available in fits and spurts, and we're working strongly to try and get it to a collective sense, be able to publish it and then figure out what to do with it, whether from ourselves, the dealer, mechanics, or the consumer itself.
John, let's talk about the enterprise sector for a moment. Can you provide us with a use case whereby Ford as a company can benefit from the data gathered on your vehicles?
Sure. Right now, for example, some of the data can be used from the standpoint of warranty-related matters. The ability to understand, I mean, in the physical space, we have things called wear and tear, things wear and tear depending on the environment and whatnot. When we build vehicles, we build based on a model of what we expect the wear and tear to be, based on understanding both historical as well as understanding the geography of the region. But again, having more localized information and understanding of a particular thing would help us both from a warranty perspective as well as the maintenance of your car. And that's data that therefore would be exceptionally interested in. Again, it would help us make your car ownership experience a better experience. From the standpoint of the enterprise, case in point, our fleet management solution called Crew Chief, some of the data that we make available includes whether the seatbelt's buckled or not, harsh braking, whether the vehicle's being driven harshly, or excessive speed. And under consent from the companies that we sell to, we use that data then to inform people of driver behavior. So for instance, as a company owner, you have liability depending on your drivers and their use of fleet vehicles. So this data is used by them in conjunction with us to help them better manage their fleet, better manage their drivers, and adhere with local laws throughout the world that they're operating in.
Now, John, you just touched on this just a bit, but are there other significant supply chain risks that can be mitigated or even solved by the data collected on your vehicles?
Certainly. I mean, we can talk about supply chain from the standpoint of depending on where the vehicle's at. For instance, the vehicle itself could be a sensor that starts announcing itself as soon as it's turned on in a factory and as the vehicle is sort of transited through the supply chain. So from a Ford manufacturing plant onto a truck or onto a boat, then to a truck, and then to the dealership, and then ultimately to the customer. That's all part of the supply chain. Certainly it's not the supply chain as Ford might think of it from the building of the car, but it's the supply chain from the experience of delivering the car. So from that standpoint, the ability for us to understand state of the vehicle, state of charge, is the vehicle operable, has anything happened to it from a weather condition, things of that nature. We certainly are looking forward to exploring how better to use the connected vehicle and some of the sensors that we have on that vehicle in that part. And then also just the generic supply chain, or the more typical or traditional version of a supply chain. How are parts operating? Are they operating well? Are they operating to conformance spec, et cetera?
John, where's the challenge in determining what data should be stored and computed on the vehicle itself, and what data should be stored and computed in the cloud, let's say?
That's a great question, and it's a challenge that we face every day. For us at Ford, we have a general operating principle, and that is if you have safety critical things that need to be handled in the safety critical space, if you have things that must be addressed in the space that happens right then and there, we must then be able to do them on vehicle. They must be done on vehicle. Anything else that's not safety critical then can be done off vehicle. And so from that standpoint, if you're going to look to chime a vehicle, if you're going to look to indicate to a driver some immediate action that needs to be taken, example, apply a brake, you're in excess of the speed limit, etc. Those things have to be done right there and then on the vehicle. But all the other data then could be post-processed off-board, and then analysis be done after the fact.
As you know, John, Ford has been around for over a century. What are some of the legacy issues that you have to face as Ford enters this age of big data?
So the big data question actually is maybe a proxy for just connectedness and sort of maybe computation, et cetera. And some of the legacy items we have to handle is the idea of platforms. So it's an issue that faces a lot of traditional manufacturing companies as they evolve themselves to understand that how you get to a platform, the ability to then apply quick cost savings in terms of applications of sort of patterns, analysis, data gathering, et cetera. So one of the biggest issues that we're facing now is working to figure out how to coalesce all the electrical architectures, all the architectures that have evolved over the ages into a single global electrical architecture that will then allow us to apply the instrumentation, which will then allow us to apply the data gathering techniques, and then which will allow us to apply the patterns and the analysis after the fact. That's probably one of the biggest challenges that we face historical. There's some others, but that's probably the biggest one that we're looking forward to over the next, and again, that's multiple years for us to solve, but it's one that we're looking forward to aggressively, especially as we're starting to enable more and more of our vehicles to be connected.
John, I mentioned in the introduction that you're the head of the Ford Developer Program. You're also in the business of selling cars, obviously. Is that why Ford adopted the open source approach to attracting as many developers to your vehicles as possible?
In part, yes. I mean, I get the question a lot. Why are we doing a developer program? Why are we giving stuff away? Don't you need to make money off of it? I mean, at the end of the day, we sell cars. That's what we do. But we recognize that our customers, you, for example, if you drive a Ford, you demand and need your content brought into the vehicle. You demand and need and want connectivity options, whether it's simple USB, whether it's the ability to actually be able to move content from your vehicle off or off-board and on-board. Your demands and needs are far greater today in terms of connectivity than they've ever been in the past. So with that in mind, we then need to figure out how do we enable that. And experience has shown, just not for Ford, but across the board, if you open things up, if you open a platform, if you give third parties the opportunity in a safe and reliable manner to build and extend your platform, they will, and they will do it in such a way as to drive incredible purchase behavior. So for us, we're trying to sell more cars, and we see this as a great way to do that.
John, the connected space is an interesting space for us to cover, and it's even more interesting when you add it to the telematics world. So it's nice to have somebody like you to bounce things off, if you will.
Well, thank you very much. I'm always happy to talk about it.
We appreciate it, John. And thanks again for watching TI Now's channel on the network of the future. And if you haven't registered yet for TIA's annual conference in Dallas on June 3rd through 5th, please go to TIA2014.org and click on Register Now. So long.